Welcome. Thank you for your interest in this experiment. It is a rough first implementation of my personal ideas, full of potential for improvements. The working title for it is Simulated Location, as it's possible to select any location and check if the AR experiences at these locations are working as expected. As already said, it's an experiment, not a final product. Its purpose is to get feedback if and how parts of it should be offered by OpenAI Cloud to make using its services easier and more useful. Here you see the still empty home screen of the Spatial Content Discovery Administration application. Lots of space for account overview, content status, and so on. Loads of potential for future experiment. Any ideas what should be here? Let us know. Main features of the application are accessible in the menu. Let's create a new spatial content record. Here you see a simple one-to-one implementation for it. Works, but isn't very accessible, full of abstract values of visual elements. How about an uploader/selector of content from various storage providers, especially edge storage providers? The fields for type, title, and the references could be filled in automatically by selecting the content from a list of files stored in the Edge or cloud, create a thumbnail of the content, and so on. This is for another screencast though. For the sake of this screencast, I fill in the info I need using the demo button. I have added a GLTF model to be placed at the geopost below and an image I need later for localization. That is likely not according to spec, just for the demo. Once an entry is added to the refs element, the geopost editor becomes available, which is the actual subject of this screencast. My first suggestion for an OSCP tool is a specialized map. Here it is used to select the lat/lan parameters for a geopost and visualize the coverage of spatial services at the respective location. The same map is actually also used for the client application to select the location for the spatial service search. Different functionality, same map component. What's different is the panel on the right. Depending on the task, a different panel can be dynamically loaded to offer different functionality. What could also be variable is the tile service used, free or paid, depending on the requirements of the task at hand. For the demo, I select a location in a small city full of traditional houses. I can then request the geopost services available at this location. Their coverage is shown on the map and I can select the one to use. Clicking on Check opens the screen to establish a real-time connection with a mobile device using WebRTC. Scanning the QR code opens up the client app on the device and establishes the connection automatically. Once the connection is established, UI elements allowing control of the display on the device are displayed in the admin application. Changes done here can be sent to the client and immediately applied to the AR session, which is not implemented yet. When the device is capable of the required AR features, a button is shown to start an AR session. There, the photo in the refs element of the spatial content record is used for localization. Then, the map of the area and the model are downloaded and displayed at their respective locations. Now, the correct placement, functionality, quality, and so on can be verified as if being at the actual location. When you watched closely though, you may have noticed that the height value of the geopost was 0, but the 3D model is actually sitting on the ground. Correct, my bad, will be fixed. So, the model should have been shown 640 meters below ground, which is very likely wrong. For situations like this, there could be a verify button, which checks for common mistakes, offering to fix them. In this case, to enter the ground level value from the localization into the geopost and send the correction also automatically to the admin app. You may wonder, why to use an AR session for this functionality instead of a simple VR view? Well, the code used here should be the same as for the viewer used by an end user. The only difference is that the viewer uses relocalization and not a simulated one. When something is working here, the chances are high that it's also working with a viewer. So, what do you think? Makes sense? What is needed to make it even better? Any constructive feedback, support, collaboration is very welcome. Again, neither the admin app nor the client app are intended to become a product from OpenAI Cloud, but the modules might, like Map, AR View, Upload, Select, and so on. All to make using the services we are building easier and more reliable to use. All for free and open source, of course. You can try this demo out for yourself on admin.browser.app and have a look at the sources in the OpenAI Cloud organization on GitHub. Hope you think this screencast was worth your while, and I hope to hear from you soon.